Okay, let's jump right in. What if I told you that you could take some of the grossest, dirtiest water you can imagine and make it crystal clear, and do it all with about $7 worth of stuff in an old plastic bottle? Well, that's exactly what we're going to do today. We're building a filter that can do just that.
Now, to really appreciate what this thing can do, you have to see where we're starting. We are talking literally about ditch water. You know, that standing water on the side of a field. It's murky, it's brownish, and it has that distinct smell of wet dirt and just stuff decaying. Yeah, it's water you wouldn't even want to dip your finger in. And yet, after running it through this simple, homemade filter, this is what you get. I mean, look at that. On the left, you've got the before, all murky and nasty, and on the right, the after, completely clear, no smell at all. It's an incredible difference, which brings up the big question. How on earth is that even possible?
That's exactly what we're going to break down. We're going to get into the science of how you go from ditch water to water that's on its way to being safe to drink.
So, first things first, this is not a magic trick. It's science, and it's the very same principle used by professionals in some really tough situations. We're talking emergency relief operations, field hospitals, and serious wilderness survival courses. This is a proven, reliable method.
The whole secret, the real key to all of this, is in the stack. We're going to look at how layering different materials in a very specific order is what makes this whole amazing transformation happen. And what's so cool is that you already get this principle, even if you don't realize it. It's the reason your fish tank filter has charcoal in it. It's how that Brita pitcher in your fridge works. It's even a huge part of how cities treat our water on a massive scale. It's all about those layers. So, the technical term for this whole process is layered gravity filtration. Basically, gravity does all the work, pulling the water down through a stack of materials that get finer and finer. Each layer has a specific job to do, you know? The top layers catch the big chunky stuff, and as the water goes down, the next layers catch smaller and smaller particles, all the way down to a layer that can pull out dissolved chemicals. All right, enough with the theory. Let's get our hands dirty, so to speak. Let's look at how you can actually build one of these yourself. Here's your step-by-step guide to that $7 filter. And the shopping list is just awesome. It's so simple and cheap. You need a 2-liter plastic bottle, which, let's be honest, you've probably got one in the recycling bin right now. Then, the most important part, aquarium-activated charcoal. And I gotta stress this, aquarium charcoal, not the briquettes for your grill. Then you just need some fine sand, some coarser sand or small gravel, and a few cotton balls or small piece of cloth. That's the whole shebang. Okay, here's how you put it together. Cut the bottom off the bottle and flip it upside down so the neck is at the bottom. You start from the bottom and work your way up. First, pack those cotton balls into the neck. That's just to stop everything else from falling out. On top of that, about 2 inches of your activated charcoal. This is the magic layer that pulls out odors, colors, and a lot of chemicals. Then, a couple inches of fine sand to catch all the tiny gunk. Above that, a few inches of coarse sand or gravel to catch the bigger stuff. And finally, you just lay a piece of cloth on the very top to keep the whole thing from getting clogged up right away.
And I want to pause here for a second because the order is everything. It has to go from coarse at the top to fine at the bottom. If you get the layers mixed up, you're not filtering a thing. You're just running water through a bottle of dirt.
Okay, so you've built your filter, you've poured the dirty water in, and what's coming out looks perfect. But right now, this is the most important part of this entire explainer. We absolutely have to talk about what this filter misses, the invisible dangers that can still be in that perfectly clean water.
Let's look at the report card for this thing. Does it get rid of the suspended solids? You know, the stuff that makes water cloudy? Yes, it does. Does it remove a lot of heavy metals and chemicals? Yep, that's what the charcoal is for. Odor and color? For sure. But, and this is the giant flashing red light, what about viruses and bacteria? The answer there is a big, hard no. This filter alone cannot, and I repeat cannot, make biologically unsafe water safe to drink.
So let me be 100% clear. At this stage, the water looks clean, it smells clean, it probably even tastes clean, but that water is not safe.
Not yet.
So what do we do about those threats you can't see? What about all the nasty little pathogens that could be swimming around in that beautiful clear water?
This brings us to the final, and I mean absolutely vital step in this process. Here's how you take care of those biological threats and make the water truly safe to drink.
It is a simple 2-step safety protocol. Step 1, you filter the water to get all the physical junk and chemicals out. Step 2, you disinfect it.
And the two easiest ways to do that are to either bring the water to a full rolling boil for at least 1 minute, or if you can't make a fire, add 2 drops of plain unscented household bleach for every liter of water and let it sit for half an hour.
And you guessed it, the order here is critical. You must filter before you disinfect. Why? Well, think about it this way. All those little bits of dirt and organic stuff floating in the water will actually attack the bleach and use it up before it ever has a chance to kill the dangerous viruses and bacteria. Filtering first clears the battlefield so the disinfectant can actually do its job.
So now you've got a skill that's part cool science project and part essential survival technique. But I want to zoom out for a second and talk about why this simple knowledge is so much bigger than just a DIY project.
According to the World Health Organization, there are 2 billion people on this planet who get their drinking water from a contaminated source. Just let that number sink in for a second. That's more than 1 out of every 4 people on Earth.
And the consequences of that are just staggering. Every single year, an estimated 485,000 people die from diseases caused by contaminated drinking water. This isn't just a minor problem. For millions, it is literally a matter of life and death.
But here's the kicker, the really ironic part. This isn't new technology, not at all. We have records of ancient Egyptians using charcoal to keep water fresh on ships. Slow sand filtration was officially documented back in 1804. This is ancient knowledge. We just sort of forgot about it when clean water started conveniently flowing out of our taps.
And that kind of leaves me with a final thought. This powerful, life-saving technique is thousands of years old, just waiting to be remembered. It really makes you wonder, doesn't it? What other simple, brilliant solutions have we forgotten along the way?
And that's it for today's breakdown. I really hope you learned something you can actually use. If you did, do us a favor and hit that like button, and make sure you're subscribed so you don't miss our next explainer. We'll see you then.